Okay, good afternoon. So yes, I work for Amadeus, and I'll just explain quickly, firstly, what we do at Amadeus, and then I'll talk to you about why we're building a new application platform to host our services using OpenShift and Kubernetes. So basically, we provide services to the travel industry. We help content providers, for instance airlines, publish the seats they have on planes and sell them. Hotels sell their hotel rooms. The content distributors, online travel agencies, they can sell through us. And we also link up with the actual operators of services. So, for instance, airports, ground handlers, rental car companies, etc. But we don't just channel data around, pump data from one place to another. We also provide turnkey solutions. For instance, inventory, airline inventory, departure control systems, flight management, etc. So we have quite a lot of volume. For instance, we boarded 695 million passengers last year. And we do this from our main data center in Germany and a disaster recovery center. In terms of traffic, customer and internal traffic, we had a peak, for instance, last year at 210,000 queries per second. We have on average about 145,000, so there's a fair amount flying around. We have all this running on a fairly large distributed system, service-oriented architecture. It's powered by around 5,000 microservices. When I say pseudo-microservices, it's because they're a little bit big. You might not feed the teams off 2 pizzas for one service, say. And all this is powered on thousands and thousands of application servers. The main problem we have there is that these servers, they have assigned roles. And so when one of them breaks, we have to fix it, nurse it, stroke it, and bring it back into production. And that's the kind of model that we want to get away from. Where we want to go? Firstly, we want to get closer to our customers because we want to reduce latency. Everyone wants quick response times. And that's an increasing tendency throughout the world. So we want to be able to implant our systems closer to our main customers, who are, for instance, the actual content distributors, etc. Passengers don't interact necessarily directly with us, but it's more the airlines and the airports and things like that. We also want to be able to do what we call remote operations. By that I mean we want to be able to actually install appliances on certain customer premises when it's appropriate for the business. Again, to reduce latency to the absolute minimum. To do this, we need to be able to go beyond our single or dual data center model and deploy in data centers throughout the world. We also think that we need to be able to gain a cloud capability and deploy into clouds like Amazon or Google. And finally, we'd like to evolve our current data center to become more flexible, more agile, and more cost-effective. So to do this, we've chosen to build a new application platform, which we're referring to as Amadeus Cloud Services. It's our end product. It's not something that we're actually going to sell. But we're going to use that to host our applications. And we're building it on top of Google's Kubernetes and Red Hat OpenShift. Now, where exactly does Kubernetes come in? So the first major point from our point of view is that it allows for application-centric deployment. You deploy an application with all its dependencies, all the libraries, etc., everything above the kernel. And this is very good for reproducibility. Wherever you deploy your application to, it's going to be exactly the same. It can be on your laptop, it can be on test, in staging, in production. It's always going to be exactly the same thing that you deploy. It's also technology agnostic. By that I mean that we can deploy C++ applications, Python applications, Go, whatever you like. It's all packaged, so it's a black box to the system, and you don't need to know. So you have low adherence with the operating system. It's also much simpler for operations because they don't need to worry about all the icky configuration bits about what's inside the application that's being deployed. The next major point is about automated scheduling. Basically, you give tasks to Kubernetes, and Kubernetes schedules them for you. It takes care of making sure that what you've asked to run is running. And it's a declarative system, not an imperative system. So if there's any deviation because a box falls over or something, then Kubernetes will take care of making sure that the system gets back to the situation it was supposed to be in, the situation that you described to it. So all this self-healing and configuration drift avoidance is extremely important to us. And overall, yeah, decoupling what runs from where it runs. A few other points that are of interest to us. The fact that Kubernetes allows you to deploy to various clouds, Amazon, Azure, Google, or also to infrastructure as a service systems like OpenStack. The fact that it's designed to accommodate constraints. So by that I mean it doesn't force you to have HTTP as your inbound protocol. We deal with lots of different systems, airline systems, etc., hotel systems, and not everyone talks HTTP to us. So we need to be able to accept any kind of traffic, and Kubernetes allows for that. Last point, it's open source software, and that allows us to collaborate with Google and Red Hat on the evolution of the software. It allows us to exchange with the community because we benefit from other people's ideas, but we can also contribute back and also bounce our own ideas off people and see whether they are actually worthy or not. So just to conclude, the three main points that Kubernetes brings are automated cluster management, simplified operations, which is something we see as being an enabler later on for a DevOps model, more and more automation from all the way through the chain. And also it's been just great collaborating with the Google and Red Hat teams, and I'd just like to say a big thank you to everyone who's been contributing to Kubernetes over the past year or so. Thank you very much.